here we go again. It's lesson 55, and we're off to a good start as we're looking at rate and average multi-step problems. And don't let this scare you. It just means, hey, let's think about this. Let's work hard at it. Let's be successful. Let's take a look at our first example. It says the average of three numbers is 17. What is their sum? Now, from first point, you may be sitting there saying, just give me the answer. But now look at this. How are you going to solve this problem? Feeling a little stuck? Let's talk it through. We don't actually know what these three numbers are. And the fact is there's actually a couple different possibilities that you could have to get an average of 17. But there's something about our average formula that we know. We know that when I take my first number plus my second number plus my third number and then divide them by 3, because that's how many numbers there are, it's going to equal your average. With that in mind, the fact is this is what my question is looking for. I'm looking for this sum. And in essence, I'm looking for one value. I don't actually have to know the three values to solve it, because all I want is the sum. And so in the end, I come away with a new problem. The sum divided by 3 equals 17. Which means that if I rearrange this and solve for this, if I take 17 times 3, I'm going to get the sum. So this is the big principle that we want to understand, that you can you probably want to write this down, that the sum of an average problem is equal to the average times the number that's being averaged, the number of numbers. Right, so we're just rearranging the idea. And so to solve this problem, we're going to take 3 times 17. 2 times 7 is 21. 1 goes down, 2 goes up. 3 times 1 is 3 plus 2 is 51. So we get a final sum of 51. And so as we look at this, we get this idea that we can keep in mind. And we want to keep this idea in mind as we continue working through these problems, because it helps us to do multi-steps. So this first problem really wasn't a true multi-step problem, but it gave us this principle that the sum is equal to the average time times the numbers. Let's try it with this one now. It says the average of 4 numbers is 25. If 3 of the numbers are 16, 26, and 30, what is the 4th number? Okay, well, here we need a multi-step function. First of all, we know our first 3 numbers. We know 16 plus 26 plus 30 plus an unknown equals the sum. So in essence, we have 2 variables. So how are we going to get rid of one of those? Well, we just learned a trick, right? Just with this information, we're able to figure out the sum. We know that the average is 25. The number that we divided by was 4. And so now if we multiply it, we're going to get the sum. So 25 times 4 is 100. Okay. Now that we know that this number is 100, we can plug that in here. And now we have a new equation, step 2. So now we have 16 plus 26 plus 30 plus x, our unknown, right, our 4th number, equals 100. And so with that in mind, we can add our numbers together. And so 26 plus 16 is going to give an answer of 42, plus 30 is going to give an answer of 72. So 72 plus something equals 100. And to solve that, of course, is 100 minus 72, which gives you a wonderful answer of 18. Who's doing the math here? Let's try 28. Oh, you would just write whatever I write, wouldn't you? Probably. That's okay. Found my mistake, fixed it. So our final answer is 28. So we have this idea. So don't forget this principle that we talked about, being able to find the sum using those different parts. Let's move on to the rate portion of this lesson then, and talk about multi-steps with rates. It says after 4 years, the average number of students participating in after-school sports was 89. How many students must participate in the 5th year to bring the average to 90? Okay, let's stick with average and continue working with this and see how we would solve a problem like this. So basically what we want to do is we want to change our overlying average. And so what we have is we got to take the information given to us. So we have 4 years, average of 89. Okay, so how many students are participating then? What's the sum of the students? Hopefully you're saying, okay, we've already learned that to find the sum, we're going to take the average and we're going to multiply by the number, in this case, the number of years. So 89 times 4. When we take 89 times 4, we get an answer of 356. Okay, well, how are we going to adjust this to get to an average of 90? Well, how much is the adjustment need to be made by, right? If next year, after the 5th year, it's 90 times 5 gives us the sum, suddenly we have a new number. We have this number, just like this, 450. Okay, so now we have two sums, but still, what are we going to do with this information that's going to allow us to work things out? And here comes the really cool trick, is if I take the sum from 4 years and I subtract it from the sum of the 5th year, so if I take 450 minus 356, just like that, I'm going to get an answer of 94. And this difference that we've just calculated is going to give us the answer we're looking for. By finding the difference between the two sums, we find the number of students that needed to join to get us from our initial sum after 4 years to the new sum after the 5th year. And so 94 more students joined the sports program. And by adding 94 to our 356 and then dividing it by 5, now we get a new average of 90. If you're not following me right now, jot down a question in your notes and bring it up in class and we'll talk about it. All right? Just for clarification. If you followed me the whole way through, all right, good, great. Now on to that rate problem. Tyrone is buying refreshments for the next math club meeting. It says brand A cranberry juice is on sale for $3.20 for a 64 fluid ounce bottle. Brand B costs $1.90 for a 17 fluid ounce bottle. Which brand is better to buy? So this is a rate problem. And because we have a rate, what we really need to figure out before we can really determine which one is better is to figure out how much does 1 ounce cost. So right now we're looking at the fact that bottle A is $3.20 for 64, but now we need to know if I had 1 ounce, how much am I paying? Once we solve for that, then we're going to compare that to our other one, right? We have our $1.19 for 17 ounces. The question is, how much for 1 ounce? So as we cross multiply and divide, or basically just go ahead and divide, we're going to get this figured out. So what is $3.20 divided by 64? And then of course, what is $1.19 divided by 17? Now, you could take time to solve that by hand. You have the skills, you have that ability, and you would come away with these two answers. Right? 5 cents compared to 7 cents. Now that we figured that out, now we know what the actual rate is. This is 7 cents for 1 ounce. This is 5 cents for 1 ounce. And so in the end, brand A is the better buy. So the bigger one ends up being better. Not always true, but in this case, it works out. Hopefully, it's healthier. But that's not what we're debating right now. All right, that was a lot of samples, a lot of different ideas, multi-steps. If you have questions, be ready to ask them and work this through. Here's a practice problem for you then as you work with, once again, a rate. And you can see broke down step by step to see all the multi-steps you would need to come away with the final question, which would be the big question we're asking: what was her average rate of pay for the whole week? And so we need to break it down step by step to be able to do this. All right, that is lesson 55. That's it. See you in class.